Uh, Good morning, everyone. I'm Mian Shafiq from Nazarbayev University, Kazakhstan. And my speech today consists of a topic which is very important nowadays about the artificial intelligence, like generated artificial intelligence assistance in petroleum engineering, a performance study of numerical problem solving capabilities of different AI tools in petroleum engineering. This is the topic of my research today. And in this, we are going to discuss about generative AI, including ChatGPT, Gemini, Claude 2, Copilot, Perplexity, and DeepSeek in solving the numerical problems which are related to petroleum engineering. And just let you know that in this one we have total 62 total numerical set problems. And of this 24 problems consist of formation evaluation, 15 about drilling engineering, 10 about production engineering, and 8 about well logging, 8 about well testing, and 6 enhanced oil recovery problems. We have the big data set and we use all the tools mentioned in this on this data set to check the efficiency of each model. Initially, these problems are solved manually, and then the same problems are entered into the generative AI tools one by one with separate commands, separate prompts, while the command is same throughout the uh, and only the first solution of generative AI tools is noted. Okay, and the tools like which we and the results we are going to see basically based on RMSE. Okay, and let me start. So if you see here this diagram, it shows the tools or it shows the framework. Okay, like for example, the first step is the geology and geophysics study. Exploration. After exploration, we go for the development of the oil field, and after development, we go for the production, and production after production, we go for the storage, and then finally we go for the abandonment. That's basically the life cycle of the oil field. So basically, with the emergence of this AI revolution in different industries, so petroleum engineering is not left behind. And with the oil and gas industry becoming more sophisticated and more challenges, so reservoir characterization become challenge. And with the use of these artificial intelligence methods or artificial tools, it becomes easier to find the accuracy, the relationship between different parameters, and we can go for the appraisal and development of the field. So that's why these are very important, and that's why in this research we check the effectiveness of different tools. So what about the rise of the AI, the rise of generative AI in engineering? So generative AI basically is built on language models which are known as LLMs, okay, and deep learning models, and has been very effective in natural language processing, code generation, and problem solving across various domains. And that's why it's very important to learn these process data and generative information solutions and insight that can be helpful for human, that can be helpful and that can surpass the human capabilities. So generative AI has started to change the traditional workflow in engineering by automative repetition, because generative AI can combine vast amount of production, geological, geophysical, and drilling data and find patterns and connections that human analysis would miss. And it has the potential to transform completely in the field of petroleum engineering. The study of collaboration between humans, artificial intelligence is further fascinating, and it is very good if you learn these AI techniques. So the finding of this study about like how these AI tools are going to analyze the data in different fields of petroleum engineering basically signifies this study. So what is AI advancement? So AI has advanced at an unprecedented rate during the current, or you can say during the current era of the past 10 years. And it is mostly caused by the combination of three factors: the growing availability of the diverse and substantial amount of data, the development of and sophistication of the AI infrastructure, and improvement in AI model building techniques. So these include like transformers, it can include diffusion models, it will include generative adversarial networks, and the harmony of all these factors basically has increased the AI potential, laying the groundwork of development for AGI. And the advent of AGI did not arise from a single source, but it was a product of, you can say, uh, symbolic relationship between academic and industry. And significant breakthrough came in 2017 when Google open sourced the transformer architecture, which replaced the traditional neural networks with self-attention methods of processing equal representation of you can say equal representation of AGI data. And now I will say something about the this figure. If you see this figure here, okay, it shows that LLMs are shown on the left side. Okay, the left side of the figure is basically the LLMs like Goma, Grok, Claude 3, like this type of LLMs, while the multimodal AI models are shown on the right side. Okay, the curve on the timeline represents the current development in AI. According to the Lee et al. In 2024, multimodals combine the elements of computer vision and LLM to process text and visual inputs such as photos, videos, and three-dimensional objects. We see this figure is very attractive with the different LLMs and the models. So what type of challenges we face in the petroleum industry? Uh, the main challenge we face in the petroleum industry is basically the huge data set available to us from the field. And these data set consist of reservoir simulation, modeling, well testing, production engineering, drilling optimization, enhanced oil recovery, okay, formation evaluation, and well logging. So in addition to strong mathematical and computational skills, these problems typically require an understanding of physics, thermodynamics, geology, and to solve such issues, conventional petroleum engineering employs specified tools like specific simulation models or simulation tools to solve these problems. But with the help of generative AI helpers, these procedures can be simplified, okay, and new insights can be obtained using the AI technique. And petroleum engineering challenges stem from the non-linear multi-phase flow. Basically, the flow is usually non-linear, and multi-phase flow consists of different type of phases: liquid, gas, and in the porous media, and the inherent uncertainty in subsurface description, because we don't have the complete data set of subsurface, and coupling between the various physical, chemical, and geological processes. So that's why the petroleum engineering is very complex, and these tools may be very helpful in future prediction and development of the reservoir. So what is the significance of this research? This study gives industry decision makers a better foundation for assessing the feasibility of integrating AI solutions onto their operations by offering concrete evidence of domains in which AI is succeeding and possibly failing in processing complex domain-related computations. So these findings has implications for the development of petroleum engineering curriculum, increase industrial productivity, and development of more specified AI tools or AI applications for the petroleum sector. Furthermore, this study contributes to the current discussion of the role of AI in petroleum engineering, and which raises important issues including responsibility, liability, and the need of redefining engineering skills in the light of AI. So, if you see this figure, it will show that how our methodology works. Like first we have the problem set development, we have a set data, we have the problem, we select the generative AI tool. After selection of generative AI tool, we give standardized prompt design, and then we collect the data. Okay, is the response completely and logically correct? If the response is correct, it's okay, we can go for the validation, and if it is not, we will go for the next attempt. Okay, and that's how we do this. So a diverse set of problems has been created covering major subjects in petroleum engineering, including formation evaluation, petrophysics, drilling engineering, production engineering, well logging, well testing, and enhanced oil recovery. So this is the methodology. So if you see, so the first of all is the problem set development. So what is problem set development? So problem set development is, this study is based on the comprehensive compilation of numerical problems from the various domains of petroleum engineering, aiming to evaluate the capabilities of modern generative AI assistants. Then we go for the selection of generative AI systems. That's the second step. And according to the predefined criteria, 7 generative AI systems were selected that emphasize accessibility, technical capability, and modern heterogeneity. Then we go for standardized prompt design. A single prompt design template was used to control the instruction variance across tools and minimize the comparison. Then we go for the data collection process. So in data collection process, the limit temporal drift from the model updates. All problems were issued into the 7 assistant within a 24-hour window. And then we go for the decision checkpoint. Quality control checkpoint was applied to all the response before the scoring, then the response validation. And in response validation, we have a multi-metric framework was applied to evaluate the accuracy of AI-generated numerical solutions. And then we go for the performance evaluation criteria, like how these generative assistants were tested thoroughly using a quantitative and qualitative index. So now you come towards the results and discussion. If you see these results and discussions, if you see these results and discussion, the first one is the formation evaluation. So formation evaluation is basically, if you see here, the results. Okay. So what is the main finding here? It shows that the error rates ranging from approximately -200% to +100%. ChatGPT, Claude 2, and Gemini demonstrate the ranges from approximately -200 to 100%, and ChatGPT, Claude 2, and Gemini demonstrate relatively stable performance. Okay, while the range is ±50. However, Bing shows extremely volatile, and especially in the problem 9 and problem number 11, where the error exceeds 100%. DeepSeek, it exhibits notable performance, and with the problem 16, and the error is around -20 to 100%. And Perplexity maintains the moderate consistency, but shows substantial negative errors around problem 8, 9, and 17 to 19. So the results reveal stark performance difference among the models. Claude 2 demonstrate exceptional accuracy with an average error of 0.035%, presenting the near perfect performance information evaluation characterization. That's about this one. The best one is like Bing. Now if you go towards the drilling problem, in drilling problem, if you see here, around problem 10, okay, around problem 10, all of them, like there's error in the calculation, Okay, but however, Claude 2 shows the most extreme deviation with approximately 4,700% error, followed by ChatGPT, Bing, and DeepSeek demonstrate moderate spikes. Okay, and while Google Bard maintains relatively better control with minimal deviation. So in second figure, the average percentage error reveals significant performance disparities among generative AI systems for drilling engineering problems. Gemini demonstrates the most accurate performance with only minus 9.72 average error, indicating slight underestimation but maintaining the reasonable precision. DeepSeek follows with 68.62 average percentage error, showing moderate overestimation tendencies. Bing, like the inaccuracy, is 110%, and Perplexity performs poorly with around 200% average error, and ChatGPT error is around 184.3%. And if you consider the RMSE value, and RMSE value the figure 5, and Gemini gives the best performance, and the RMS value is around 41%, while Claude 2 the value is very high, around um, 1,237%. So the best one is Claude 2, followed by DeepSeek, and then uh, Bing and ChatGPT. Now you come towards the third results, which are production engineering. In production engineering, if you see at problem 2, Bing shows some error, while DeepSeek there is is very less. And if you come towards the average error, all of them are almost the same. But if you come towards the RMSE value, all of them doesn't show any good performance. All the values are very high. So it shows that for production engineering data, for the current data set, the all the generative AI models, the values are not good. Now you come towards the third, which is well logging. In well logging, if you see here, there is deviation in the results. And if you see towards the percentage error, Bing shows the best results, followed by ChatGPT and Claude 2. And if you see the RMSE value, still Bing shows the good results, the value is less, followed by Claude 2. So these results are basically the percentage average error and the RMSE value. Basically, they are complementing each other for well logging problems. And now we come towards the well testing. In well testing, if you see at problem 2, the Gemini shows some error, and problem 7 also they show some error. But if you come towards the average percentage average error, the percentage average error, again the Bing shows good results, and even for RMSE the Bing shows good results. It's followed by Claude and ChatGPT, same like well testing. And then if you come towards the EVA problems, enhanced soil recovery, so most of them they have negative RMSE value, and negative percentage error. Only Copilot is not good, doesn't show any negative results, but all others they have negative results, and it shows that these are basically average error, and like all of them, like they have negative effect, like negative value, and the maximum value is shown by the Copilot. And now let's go on towards the overall performance. So if you see the overall performance of different tools, so if you see here, uh, which one shows the best results? With an RMSE value from 100,000, DeepSeek performs the best overall. Okay, so the best value is given by DeepSeek in RMSE. Okay, and followed by ChatGPT. while the values of perplexity and copilot are very high in case of RMSE, and in case of percentage error, the DeepSeek, ChatGPT, and Gemini, the percentage error are less compared to the copilot and perplexity, and which shows that in all the results, like you can have DeepSeek and Claude 2 and Gemini and ChatGPT are better compared to the Copilot and Perplexity. So these are some results, and the effect of some of the AI tools on petroleum engineering dataset. So what we can have in future? The limitations of this research are assessment of a bounded set of problems that might not reflect the totality of the real world problems. Engineering issue relies on predefined uh, benchmark solutions that reflect certain solutions, strategies, and frozen in the time evaluation of dynamically changing AI models. Basically, these one like certain data set and on a certain models, and certain like models can be changed with time, that set can be changed with time, so that is a limitation. And in future this data set can be run again with newly developed prompts, and that can change the result also. So if you go towards the performance factors influencing the performance, first one is the training data. The quality of data used to develop these roles play a critical role. Then underlying algorithms, the specific algorithms employed by each model can influence its problem solving abilities. Knowledge base, the amount of accuracy of knowledge incorporated into the models can impact their ability to understand and solve the problems. And problem complexity, the complexity of the problems presented to the models can also affect their performance. In conclusion, we can say that formation valuation problems showed remarkable accuracy for certain models. Claude 2, for example, while production engineering calculations resulted in catastrophic failures across all the tools. So, production engineering problems which typically involve complex multi-phase fluid dynamics, nodal analysis, and production optimization consistently overwhelm all AI models. The astronomical error rates suggest that current generative AI architecture implements the lack of specialized knowledge and computational framework necessary to handle these sophisticated petroleum engineering calculations involving coupled physical processes. And that's it from this topic. And thank you for listening.